right, good day everyone, and welcome to today's architectural drawing class ARC319. All right, so it's been a great privilege to actually have you in today's class, even though the rain actually derailed us a lot. But still on still, we've actually made the commitment of starting today. All right, so I'll be sharing the link to this video privately. Yeah, to those who actually subscribe to this class, I will be sharing the link with you privately. Okay, so via the email you actually are submitted to me, so you will only be able to access it via the email. All right, so take note of that. All right, so welcome, and we'll be considering first of all the theoretical aspect of it. So, and as things go, I'm actually saying this thing, I think we should be starting AutoCAD class by either the second or third class. What I'm saying, yeah, by the time you're going to have a second class, we should be starting AutoCAD. Yeah, so that's just it. All right, so let me just take you through the rudiments of building drawing. Okay, your architectural drawing, as the case may be. All right, and one thing is definitely sure, I will still keep bringing up things which maybe I might actually skip during this theoretical class by the time we actually start the drawing proper. Exactly, so take note of that. All right, so welcome. So ARC319 summary. Okay, so we are going to first of all start with the concept of a building. All right, so as we can see on the screen, a building is a structure such as a house, hospital, school, etc., with a roof and a wall used as a place for people to live, work, do activities, store things, etc. That's it. Okay, so a building is a structure which has a roof and a wall. So that's just it, which has a what? A roof and a wall. Now you'll be amazed that why did they say which has a roof and a wall? A tent is not a building. That's why they actually name it a tent. All right, yeah, a tent has a covering on its top and has tarpaulin on the body. All right, but that can be said to be a wall. Okay, yeah, it can be defined as temporary wall. Okay, so that's just it. So a tent is different from what? From a building. Take note of that. All right, so that's it. So then we have a site plan. Yeah, so let's just go into it. Proper site plan. So in this particular aspect, we have two concepts to be considering: site plan and the building plan. So let me explain the first aspect, site plan. Okay, so a site plan shows entire construction site, including boundaries, roads, utilities, and landscaping. All right, a site plan shows the entire construction site, including boundaries, roads, utilities, and landscaping. All right, so that is it, and landscaping. All right, so a site plan also illustrates building placement within the plot. Now, site plan is different from building plan. So I'm going to actually okay, let me just actually bring everything up. Now look at this. So the second one says a site plan illustrates building placement within the plot with access points and environmental factors. So that's just it. So a site plan typically, okay, now look at this area where my pointer is actually hovering around. Okay, that is a building. Now on a site plan, you will only see the shape of the building like a grid. So you won't see all the details of that building, like the toilets, the bathroom, the everything. No, you won't see. So this is what you'll be seeing. You see, proposed addition. See, this one is proposed deck. So this one is existing two-way house and garage. So it is going to show the environment. Okay, so a site plan won't only show the position of a building. It's going to show existing structures. Yeah, like road networks, public infrastructures, and the likes. Yeah, a site plan is going to what is actually going to showcase everything. A site plan is going to actually showcase all those stuffs. Okay, so that is it. So it also ensures compliance with zoning laws and site condition. Yeah, so with a site plan, then you can actually know where to actually start your building from. So the existing they call set off line or setback line. Sorry, back off line or setback line. So there is this concept. I'm going to explain it as we progress further. So all of those things are actually determined on the site plan. They are determined on what? On the site plan. So that's just it. So a site plan won't just show your piece of land. It is going to show maybe like, let us assume you're actually building your land on something like maybe 300 square meter. So you get, so the site plan is going to show up to like maybe a kilometer coverage. Okay, area view of where your building is going to actually be imposed. So it will show existing structures, existing public infrastructure, and the likes. It's going to show everything, the road network, everything leading to your what? Leading to your building site. So that is what a site plan actually does. And also it helps visualize the project scope and partial relationship to surroundings. Okay, so that is that about that. So that is that about that. So another, okay, yeah, this is also a picture of a site plan. Okay, look at this now. Look at this. Okay, so look at this particular picture now. Okay, yeah, so this one is the proposed building, this thing. Okay, this is the shape the building is actually going to take, but you see, you can't see door, you can't see window, you can't see anything. You are only showing what a grid, GRID. That is what a site plan will actually show. And you see, it's showing the roads, the road network. You see road network, you see the road network. So see, simply when you're showing the road network, you see, I think this is something like maybe a roundabout or whatever. So you see, showing existing road, you see existing 10-story building around that area. This is your own proposed building site. See, it's going to show existing structures and the likes. Okay, it's going to show them, it's going to show landscape, everything around your site, So that is what a site plan actually entails. So a site plan won't show you the design, it won't show you the design of your building, the full detail of your design. It can only give you the shape, that you can only see the shape of your building, maybe the grid, just like you are saying here, just the grid. Okay, so it is the building plan that will now show, okay, it is 4 bedroom, it is 5 bedroom, this is the position of the kitchen, this is the position of the bathroom and the likes. Only a building plan will show that. A site plan won't show that. All right, so a building plan won't show existing structure. It will only focus on the building which you are actually erecting. So it won't focus on all of these existing structures that we have here. Only a site plan does that. Okay, so take note of that. Yeah, I think the lecture actually brings OBJ in those aspects. That's why I'm actually taking my time to explain all of this. Yeah, that's why I'm taking my time to explain all of this. I think in this exam we do bring out OBJ first before drawing, something like that, so that you won't be confused about that. So by now I believe you should be able to differentiate between site and building plan. So let us move to building plan itself. Okay, let's move to building plan itself. I'm going to do that now. Okay, so a building plan focuses on the architectural and structural details of the building. You see, instead of focusing on existing structures, the environment and the like, it is focusing on what? On the architectural and structural details of the building itself. All right, so number 2, it includes floor layout, dimensions, room arrangement and construction specific. Do you see that? Now all of these are not included on the site plan. Site plan only show the grid, like the shape, length and breadth of the building. So it is the building plan that actually shows the floor layout, door dimension, kitchen dimension, blah blah blah, you know, all those specifics. All right, so a building plan also guides the construction execution and building assembly. Yeah, that is where you have the working drawing, the depth of foundation, all of those stuff. So a building plan actually shows all of that. All right, so essential for understanding internal building structure and design. Yeah, all of those things can be seen on the site plan, but you can only get them on the building plan. All right, and this is a typical example of a building plan. Building plan actually shows the aerial view, the elevation, the sectional view and the likes. All right, so these pictures you are seeing on my where my cursor is actually hovering about on my right hand side. Okay, I think this is the assignment for past set. Yeah, so you're also going to produce something like this, though I have all the past questions which the man actually uses. I have them with me, and yeah, so that's just it. So it was some of the questions he used during my set that I actually gave them as their project work and the likes. So this is just an example here. So you will also be producing something like this by the time the class actually commences. Even before the class commences, as a project I'm going to give you at the end of this 1 month's class. All right, so I'm going to give you a project, and to be precise, I'm going to give you one of the man's classwork or whatever. I'm going to set a fresh question for you entirely, so that let's see how you can actually your creativity. All right, so that's just it. So you can actually see the difference between a building plan and a site plan now. So that's it. So look at the one I have here. So you see, look at this area here now. You can see I have bedroom, I have kitchen, I have toilet with the dimensions there. I have window, I have doors, I have everything. All of these are not available on the site plan. You can only see them on the building plan. Look at the one I have towards my bottom left hand corner also. Okay, so that is a building plan for you. That is a building plan for you. All right, so from there we move to differences between site plans and building plans. Differences between site plan and building plan. All right, so and the first one there is site plan, the where. Site plan talks about the where your building wants to be established, where your building is going to be erected. So site plan generally talks about the geographical location of where a building is to be established. So first one there is it shows the entire property and its boundaries. It includes topography, landscaping, and utility lines. It indicates the building's position on the plot of land. It is essential for zoning and permit application. Now, if you want to apply for building permit, you need to go with your with your site plan. Yeah, because the site plan will let them know, okay, this building is on the site plan. The statutory people, okay, people who deal with the statutory permit and everything. Yeah, so they will actually see the position of your building, look at it, look at everything, and say, okay, then they can approve it. They won't just approve your, yeah, they approve the building plan also, but the site plan is also important before they can actually give an approval for a building plan, because they must actually know the location, existing structures in the area, and the likes. Now imagine you are actually purchasing a land very close to the airport, Haygate at the airport. Now you now design maybe a high-rise building, like a 20-story or 30-story building, and you now take it there. So without the site plan, they will have actually approve the building plan. Okay, the building met specification and everything, and approve the building plan for you. But with the site plan, they will be aware that, oh, this area is actually closer to the airport, so they can't permit high-rise structure closer to the airport. So with that site plan, they will disapprove that building, and it is actually going to be actually good for you to actually be aware of that before erecting the structure. Imagine maybe you were trying to bribe away, you didn't submit the site plan. You know, Nigeria is, God will just save this country. Sure, you get. Now you bribe away, blah blah blah, they approve the building, and you now erect a high-rise structure beside a airport. So that is, you know, a plane can just crash into that sort of building anytime. That was just it. A plane can actually crash through that building anytime, any day. All right, so that is it. So that is why site plan is actually what needed. All right, so another one, we have the building plan. The what? Site plan is what? Is the where do I want to erect my building. Now the building plan is the what am I erecting at the where. What am I erecting at the where? What am I building on that land? That is the building plan. So the building plan shows the building's layout, room by room. Yes, so I want my room to be king size. I want the kitchen to be like this. I want to be as big as this. Here you get all the features on the inside. Here you get. So a building plan actually shows building layers room by room, including dimensions, structural elements, and materials. Okay. For the floor, they should use also and so. For the wall, they should use also and so. So the building plan actually provides the details to all of those. Okay, so it also provides floor plans, elevations, and sections, as I explained in the previous slide. Okay, so it guides the actual construction process. All right, so from there we move to setback line. So what does setback line actually entails? What does it entails? Okay, so a setback line. Okay, let me actually paint this scenario. So let me paint this scenario. Okay, I think I'm going to actually go back to okay, let me read this before I actually go back to that slide which I put up there. So let me read this. A setback line in building construction refers to the minimum required distance that a building or structure must be from the property boundaries or other predefined features such as road, rivers, or other buildings. Setbacks are regulated by local zoning laws or building codes and are used to ensure adequate space for light, air, privacy, safety, and accessibility in urban planning. Okay, all of these grammatical jargons I actually read just now. So let me just explain it in a layman term. Okay, so I think let me go back to this. Let me explain it using this. Now look at this. You know, I actually said this is our proposed building. Okay, Sunset 2-story office building, and this is the shape of this building. All right, now from the shape of this building, this is existing road here, this is existing road here. So you know, Nigerians, we are funny. You can say, after all, I am the owner of like this. Now is I think from this area, yeah, from this area, this is your land. All of this area, this is your own plot of land. This is your land. So you see that line that I'm tracing. Okay, that's the plot of land you actually paid for. Okay, that's the plot of land you actually paid for. Now you might say, I want to finish my land. I want to use all my land finish, and you now carry your building. Okay, you now start building from somewhere here. Imagine you now said that, okay, instead of this area to be here, you now set it somewhere here, very close. and you are doing hard road, you now set it, you can see the rail line. You see, it's actually close to the boundary of the building. So under normal standard, this is actually wrong. It is wrong to erect your building very close to the land boundary, and that is the reason for what? For setback line. Okay, now imagine, let's say maybe in the next 15 or 20 years, the government want to actually expand the road. It is going to affect some of your building. That's just it. Now, I'm not saying that if you actually follow the rule, having a setback for your building, that maybe in the next 15 or 20 years when the government want to expand the road, it won't affect your building. Even if it's going to affect it, it's going to be actually maybe small part. It won't really affect a lot compared to somebody who actually erect. I say I want to finish my land, I want to pack up my land, finish. You now move your building very close to the edge of the land boundary. No, that's just it. And I think in Lagos State, there is a setback line. It depends on actually on the road. Okay, so maybe a federal road, a state road, or a street local road like that. So I think for is it federal road? No, I think for state roads, yeah, for state roads like that, from the middle, okay, from the middle, yeah, this is the middle of the road, from the middle of the road to the first I think from the middle of the road to your property line, yeah, middle. Let me use another color to actually distinguish that. Yeah, a blue. So from the middle of the road now, yeah, from this place, middle of this road to the property line to this place, okay, in Lagos State, yeah, I don't know whether they've changed it. In Lagos State is what? Is 6 meters. Okay, is what? Is 6 meters. 6 meters. And 6 meters, you know, 1 meter is 0.3 feet. That's 0.3 feet. So 5 meter is, 5 feet is 1.5 meter. So 5 times 4, that's 20 feet, roughly 20 feet. So from the middle of an existing road, yeah, a state road, okay, from the middle of this road now, bam, to the boundary of your building, of your land, of your property, should be what? Should be 20 feet. Should be what? 20 feet. And also, from this building, yeah, from the boundary of your land to the wall of your building, also it must be what? It must be 6 meters. Another 6 meters, that's another what? Another 20 feet. So which means roughly from the center of the road to the first wall of your building itself is around 40 feet. Now imagine even if they want to extend the road in the nearest future, before it actually reaches that 40 feet mark, maybe if they want to go, let's say like maybe 3 or 4 lane, that's just it. It won't really affect your structure like that. So likewise on this side also, from this place, okay, to this existing, yeah, to this land boundary is what? Is 6 meters, which is 20 feet. And then from this building, from the first wall of your building to this land boundary is also what? Is 6 meters. Okay, so meaning from this first line of your building to the center of this road is what? Is 12 meters, which is what? Roughly 40 feet. Roughly 40 feet. And that is actually big enough. That is big enough. That is what setback actually entails. Okay, that is what setback line actually entails. You can see this existing story building. You can see that it didn't stand. This story building, you can see that there's a gap between this story building here and this road there. You can see that there's an existing gap there. So that is how it ought to be. That is how it ought to be. So you don't build your house closer to the road, even though you are the owner of the land. They sold it for you 60 by 120 or 100 by 50, as the case may be. A feet of land now. Okay, so you don't say no building regulatory agency will approve your building plan for you, and that is the reason why they want to see your site plan. So on the site plan, you will have shown the setback line, everything on the site plan. With that, they can now approve your building for you. Because if you don't show them, they won't approve your building for you, and that is the advantage of getting approval before erecting a building. But you know, Nigeria, you will say that the money I'm going to use to actually get the paper permit, everything. If I use that money to start foundation, say I will almost finish the building. Yeah, but it's actually necessary you actually do all those stuff so that later on in the nearest future you don't get affected. Imagine you're doing you are selling fish, you are a fish seller, you are doing aruru, you didn't want to actually follow this regulation, and you build your structure. Maybe you started your building from somewhere here. Okay, you started it from somewhere here, very close, somewhere here. Okay, this building started very close to your boundary line, somewhere here. You can see, you know, I said this is your boundary line here. This one on the outside is your boundary line. So you get very close, and they now want to expand this roof. It's going to chop off your building. That's it. And government, they won't give you a dime because they will bring out the document and tell you that your boundary line is not up to. Now, I did you actually follow government stipulated regulations. So you get, and maybe the road they are expanding still actually incurred into your building. despite you meeting the boundary distance, then they will pay some stipends for you, yeah, as compensation. Yeah, because that is not your fault. They will pay some compensation. But in cases whereby you didn't actually need the setback line for that particular area, they will not give you. They will not give you a dime. They will not give you a dime. So that is why it is necessary to actually what, to follow all those stipulated regulations. It is for our own good. It is for our own good. All right. So I think you should actually understand the concept of setback line like that. So let me move on. Okay. So let me move on from that. So we have purpose of setback lines. Number one, safety, to ensure buildings are not too close to roads or neighboring structures, reducing fire hazard and improving emergency access. So, and I am not sure you've actually noticed this. If you've actually been to a well-organized settlement, you notice that their fence are always in alignment. Okay, their fence are what, always in alignment. The starting point of their fence along the streets, along the road, is always alignment. They start from the same level, distance to the road. Yeah, that's it. Okay, that is how it ought to be. Okay, and also to provide adequate space between properties for privacy. All right, so for ventilation and light, ensure that neighboring buildings don't block natural light or airflow. That's also one of the advantages of setback line. All right. So aesthetics, it promotes a uniform, visually appealing neighborhood. Yeah, just as I actually said, I work at the Nigerian okay, I work with a military organization, so the Nigerian Air Force. So I work at Air Force Secondary School Ikeja, and if you actually enter that base along the airport road, Sameda Air Force Base, the architect that actually do the site planning of the area makes sense. Everywhere is well properly arranged. The aesthetics, everything is top notch. So the buildings, the arrangements, the positioning of the school, of the playground, everything was well arranged, and all of those things are actually decided on the site plan. So it promotes a uniform and visually appealing neighborhood or streetscape. That's also one of the advantages of site plan. So if you are actually familiar with these people that do Katangura Estate, Pineapple Estate and the like, so they have this site plan and they ensure that the front of the building, the arrangement looks the same throughout. Okay, so and that is the work of a setback line, to show that okay, you can't just start your building from anywhere. You need to start from this particular position. So to ensure alignment. All right. So that is about that. All right. Another one is we have examples in a regulation. A typical regulation might require 10 foot. So these are just example of setback line. Okay. So in some areas they might say okay, from the front setback of 10 foot from the street. At the rear setback of 15 foot. A 5-foot setback on both sides of the building. So stuff like that. Okay. So that is that about that. So then we have, from there we go to construction team. Now if I am to erect a building, okay, you shouldn't be the Nigeria, we are just struggling. Okay, so if a young guy like me now first make my first money, the first thing is I want to erect a building, and maybe me that I'm collecting, let's say 50,000 naira salary. Yes, I'm collecting 50,000 naira salary now. So maybe I now maybe piece everything together. Sure, you get, after like how many years did I want to actually piece maybe 2 or 3 million together? I go to one bush to buy a plot of land, or maybe half plot of land for like 400k. So are you expecting me to now pack my money to go and meet all these shenanigans? Say I want to collect setback, I want to do site plan and everything. No, first thing is let me erect the building first, and I will do the paperwork later. Now imagine in that scenario, I will now go and employ a site engineer. I will say I want to employ an architect, I want to employ this, I want to employ that. I don't have the money, but under normal circumstance, if it is a country that is well structured and we have a good leader, sure you get, I shouldn't have the reason of saying I want to go and erect a building myself. Yeah, buildings should be available at even if the rate is not cheaper, at least there should be plans whereby you can actually collect buildings on mortgage, whereby they will have actually built it, and in such cases they are going to build everything up to standard. So you get, so they will build everything up to standard. Not this one, so you are hearing that one building collapse and another one collapse at Ajegune and the likes. So you get, now for me to actually erect a building, I need a construction team. That is everything I'm actually trying to say. But man will never chop. Now we collect 50,000 and no fee afford construction team. So I will be the site engineer, I will be the architect, I will be the electrical man, I will be the foreman, I will be the supervisor. Imagine, only me, everything. I want to kill the donkey. The donkey is carrying plenty load. May God have mercy. Alright, so but those of you, you that you are actually watching this recording, and those of you in class, so take note of this. So the money will be there. Okay, we have this money, we make this money. So it is required for us to actually have a construction team. That is why when you see all this construction company and the likes, they do everything in what? In order. So one person won't be doing everything. Yeah, there is a general supervisor for everybody that will be supervising everything from the top, but he has divisions under him. Now, and we call them what? Construction team or construction party. Okay, so a construction project requires a coordinated effort from a diverse team of professionals. Each team member has specific roles and responsibilities, ensuring the project is completed efficiently, safely, and to the client's satisfaction. So construction team comprises of all the people that have one thing or the other to contribute in the provision of the building. So the first parties in the construction team. So the first one here is in building construction, the project involves multiple parties, each with specific roles and responsibilities. These parties include the client party, that's the first party, followed by the contractor party and statutory personnel. Those are the three parties we have in the construction team. Take note, these are questions the man asked during the exam, I think in his OBJ also. So parties in construction team, we have the contractor, we have the client party, the contractor party, and the statutory personnel. So the client is me that actually owns the building. Babolo Odogu Male, I am the client party. Okay, so the first representative under the client party is the owner or the client. All right, the owner or the client, and my role is the individual organization commissioning the project. That is my name. Okay, that is my role. So I am either the individual or an organization. You know, to erect a building, it might be, if it is a private building, that is an individual. So if it is a public or community building, it might be a what? It might be an organization. Okay, so that is the role of the client in this case. All right, so my responsibility to define project scope, budget and requirements, make key decisions, provide funding, approve plans and changes. Now that is, I will tell them, okay, I have 20 million, I want to erect a room and parlor self-contained. All right, and I want a jacuzzi, I want this, I want that. So you get, I want POP ceiling, I want also design of roof, all of these things. So I really want making all those things. Then I have the money. Okay, now the first person I'm going to actually come in contact with is the architect. Okay, when I come in contact with the architect, that is most of the time, in most cases, as a client, the owner of you that have the money that will miss the building, the first person you actually come in contact with is usually the client. So it is now the client that will now piece the other teams together and bring everybody together. That is it. It is now the architect that will now bring all those people together. So the client will get in contact with the architect in most cases, first of all. So when I tell the architect that I want a room and parlor self-contained, I want the swimming pool to not touch the ground, to be floating mid-air, you know, those kind of stuffs. So I will tell the architect about my fantasies, about the kind of building I actually want, and he's going to try to make it a reality. Those that are not realistic, will let me know that, okay, Ogade, chairman, this can be possible, this can be possible, stuff like that. So you get, and he's going to tell me that, okay, this thing you want to do, just budget. So you get like an estimate, so something like that. Okay, so that is that about that. So the second person under the client's party is client representative / project manager. So definitely there will be a project manager, and in most cases the architect is usually the project manager, except maybe let's say one big project like that. So but in most cases, especially private residential building, the architect in most of the cases is usually the project manager. Yeah, the architect, most of them, yeah, architect, they do another person's work, because in most cases they are the first person the client actually comes in contact with. Okay, but let's just say it is not the architect in this scenario. We have the a client representative or project manager. So the client representative is the person that the client actually meets and tell, this is what I want, this is what I want, this is what I want. So that is that about that. So role, act on behalf of the owner to oversee the project. Yeah, you hear engineer. So that's it. So responsibility, manage the project from the client's perspective. So he is the client's eyes, nose, leg, and everything. But in my case, me, I will be on the side too. I will tell them, Ogade, Ogbeni, chairman, do this thing like this, I want it like this. So you get, so that's it. So the client representative manage the project from the client's perspective, coordinate with contractors and consultants, monitor progresses, and ensure the project meets the client's objective and specification. You know, I already said I want my swimming pool to be floating mid-air. So it is the client representative or project manager that will enforce that this is what Sir MaekllTech want to. He wants a swimming pool to be floating mid-air. Okay. Yeah, I think this technology Japan is introducing to actually curtail the loss of lives and property during earthquake. I think that should be, I think Leviathan technology or something like that, a floating house whereby there will be sensors and whatever on that particular on the composite of the land and the building structure. So whenever it senses that earthquake is happening, so the entire structure on that particular piece of land will float. It will float, and then after the whole earthquake, then it can come down. So it will float. I think Japan is actually working on that technology. I read it too, so don't blame me. I like reading stuff like that. Don't mind me. Okay. So the third person the client will actually meet with under the client party is the architect. All right, but remember I told you that the architect can also fulfill the role of that project manager or client representative. So the role of the architect is to design the building and create detailed plan to the client's taste. Yes, I forgot to put that one. To the client's taste, he must design it to my taste. If it doesn't meet my taste, I will not approve it. That's it. Okay. So responsibilities of the architect is develop design concepts, prepare construction drawings, ensure compliance with building codes and regulations, and oversee designs and implementation. Now look at that particular area. I think this area that actually says ensure compliance with building codes. Now look at the technology I actually mentioned earlier on. I think that Leviathan technology or whatever, that the building will float. Now imagine me telling the architect that I want my swimming pool to be floating mid-air. Sure, you get. So architect tell me, okay, this one doesn't comply with Nigeria building code. There is nothing of such in Nigeria. So this one, it is impossible, not impossible. It is impossible. Only work. It can't work. Never. So that is part of the architect's responsibility to let me know that, okay, this one can't work. I want the front to look. I want the entrance to look like that of a lion. I want the side to look like an aeroplane. Can I have you tell me, guy, this is feasible, this is not feasible? Because by the time you design everything, he's going to let you know that, okay, you said you actually want this. Can't you actually make a tweak and do it this way? So you get so as to actually ensure everything I actually want to meet building code and standards. So that's just it. Of course, if I go to Babasikira in the village, Babasikira bricklayer, so they can do everything because those ones don't actually need to go for any building code. But in the nearest future, so you get, I might actually pay for it, and that's when you start hearing of building collapse of sorts and stuff like that. Okay, so to avoid stories that touches that in the nearest future, I need to just take it to whatever advice the architect and the engineers are actually giving me. All right, so that is that about that. All right, so we have consultants also. So consultant example, you have a structural engineer. Okay, so structural engineer, yeah, so those ones they work in line with, I think, with the architect. You know, architects are actually after the aesthetics of the building. Yeah, it should be fun, it should be beautiful, it should be this, it should be that, it should be spacious, this and that. So it is the structural engineer that will let you know that, okay, this place that you said it should be like this, it should be like this. Why are you going to put reinforcement? Why are you going to actually put column and the likes? So this can work. So they will actually disagree to agree. That's just it. So that is why you actually need those people. You don't just design, the building is fine, but is it feasible when it comes to structure? Yeah. So since scenarios whereby people will say they want to, especially church buildings, they will be like, okay, the ground floor is going to be car park. The building is going to start from the first floor. Now, and they will now draw, architect will now design something clean, maybe with SketchUp or some 3D software, and you will now see the parking space on at the ground floor. You'll be like, everything is fine. Everything is fine. And now on the building, the architect only show maybe 2 or 3 column. Column is what you guys call pillar. So whenever you hear me say the word column, COLUMN, I am referring to pillar. Okay, so pillar is used by local people, the bricklayers outside. So as a student, yeah, as a learning person, you call it column. All right. So while the horizontal component is known as beam. So those are the things we actually tackle by the time you get to the drawing paper. Now imagine maybe on a wide range of land, so I can only see maybe 4 or 5 column, and I have plenty space with many designs on the ground floor for the car park, everything. There is sunshine, there is this and that. The architect design the thing fine. So you get, so the thing is doing winning, is doing anything, you are happy, the thing looks good. But when the structural engineer actually comes in, they will let you know that, okay, this thing you did could possible, it can't work. Yes, are you going to tell me, imagine that faculty of education? Okay, let's take an example of faculty of education now. So the structure that actually carries the dean's office, you get dean of the faculty office. So you're not telling me it is when they design it that they want to make that ground floor where all those inter science lab, physics lab, biology lab is, that they want to make all of those area parking space. That now for the whole of that ground floor, it is only 4 pillar. So you get from the entrance at both end, 1, 2 pillar So that's 2 column. Then at the extreme end, when you are going to tech studio, sorry, when you are going to to drawing studio, our drawing studio where our departmental office is, another 2 pillars. So look at the length of that building from the main entrance of the Faculty of Education to where tech studio is. Only 4 pillars carrying that building. Yeah, that is what an architect can actually draw for you, because they want to find, and in the picture they will do several designs and you'll be like, wow. But a structural engineer will come, and let you know that it can't work. This building will collapse. How can 4 columns actually carry that whole structure? So you get. So that is why you actually need the knowledge of structural engineers and consultants in such scenario. Okay. So their role is to provide specialized expertise in various aspects of the project. All right. So their responsibility is to offer technical advice, design structural elements, and ensure the integration of mechanical, electrical, and plumbing system. So that is one of their works. All right. So then we come to the second party. You know, all those parties I've actually mentioned earlier on: the client party, the client, the project supervisor / manager, architect, consultants. All of them are under the client's party. Now the second party there is what is the contractor's party. The contractor's party, after those ones have actually said that okay, this is what we want to do, they have the drawing, they have the approval, they have everything, then they will now look for a contractor. Now in this kind of case now, so for we that are still collecting 15,000 naira now, we contractor, okay, I just gonna look for one of my friends that is one bricklayer. Hey, Baba Lamidi, I better come, I want to do one about self-contained for one land where I get for Abuli Eleja. You get. So but under normal circumstance, under normal scenario, okay, so I need to actually look for a contractor where I award the contract, who I'm going to award the contract to. Yeah, so that is it. So if you have all these Julius Berger, all of them, blah 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 blah, yeah, they are construction company. Okay, so in most cases, they have their own architect, they have their everything. So before they actually execute a project, it will have actually gone through the government, which is the client, so you get, and the company's architect. And in most cases, maybe the government might actually have a blueprint of what they want to do. They just hand it over to the construction company and let them know that is this thing feasible? Can you go with it? So you get. So the construction company in this case is what is the contractor, and their responsibility is to they are responsible for the overall construction process. All right. So their responsibility is to manage the construction site, coordinate subcontractors, ensure adherence to plans and schedules, and oversee the quality of work site and safety. That they must ensure that the workers on the site actually adheres to the plans and schedules and oversee the quality of work. So such that if they say okay, the foundation of this area should be depth of 900 mm, so they must ensure those who are doing that foundation complies with that instruction. Ensure the depth is 900, is not more, and is not less of 900 mm. Okay, so the design, everything, they must ensure they actually adhere to it. They must ensure they actually adhere to it, and also the quality. Now if the working drawing and bill of material is actually saying the specification of material is actually saying okay, for the foundation use 3 bags of cement. You know, some people they refund you like 3 bags, okay, it's too much, let's use 1.5 for 1 bag. No, so that is the responsibility of the contractor. Yeah, because he is learned, he knows your risk. So you use the 3 bag they are providing. After all, you didn't buy with your money. So that is it. And to ensure work and site safety, yeah, so you ensure, if it is a big construction company, they will ensure that all the workers there use safety gadgets like the helmet, safety boots, and the likes. They must ensure they adhere to safety standards. All right. So we have the subcontractors, these specialized professionals offense hired by general contractor to complete specific tasks. So they perform specialized work such as plumbing, electrical, masonry, roofing, and other trades according to project specification. Now under this subcontractor, that's where you have the plumber, electrician, the builder, so you get the carpenter, and the likes, all those tradesmen, and that's where they actually fall in line. So it is the general contractor that will actually bring all those people in, that okay, I have work, this is what you are doing, so you get, and ensure you follow the specification given to you. So the contractor will actually interpret their rules to them and ensure they actually adhere to it. All right. So we have site supervisor / foreman. So the site supervisor is one that actually manage daily work activities. Okay, so we ensure adherence to safety protocol, coordinates, and also report progress to the construction manager. So there is site supervisor, and we have laborers and skilled tradespeople. So they execute the physical construction work. All right, so they perform various tasks including carpentry, block laying. Masonry is also known as block laying. So take note: electrical works, plumbing, painting, and more under the supervision of foremen and site supervisor. Okay, so yeah, as the builder might not necessarily be the one handling the trowel, the spray one and like, so he's going to have people working under him. So all those joinman that actually works with them. So that is it. Those just join men or join man and join man, those ones who carry the concrete, carry the wood, do the physical work. They are known as laborers and skilled tradespeople. All right, so you have the quality control inspector. He ensures the quality of workmanship and materials. Okay, so and that is that about that. We have the procurement manager. That one ensures the acquisition of material and their logistics. Yeah, it ensure accurate acquisition of materials, negotiate contracts, ensure delivery of materials, and manages the inventory. So it's as good as saying like site the record keeper or site supervisor. So he's going to be aware that okay, they've used 20 bags of cement out of the 60, it remains 40. So here you get. So he's going to manage all of those stuffs. So the third party now is the statutory personnel. So they are the one that actually deal with the code of conduct, the approval, all those kind of stuff. So under this, I think we have the town planning committee and the likes under this one. So all those government agency, yeah, they build Lagos State building Lagos State building construction agency. LASPCA, LASBCA, LASPCA. I think that's Lagos State one. Lagos State Building Construction Agency. So that's it. So we have the building inspector. They ensure compliance with local building codes and regulation. Yeah. So your approval, your site plan, building plan, everything will actually pass through all of these people for approval before approving them. Okay. So they inspect the construction site at various stages. That's why you might notice that if construction is going on in some area, you see some people, they will come, and if they see that you didn't comply or maybe you didn't collect approval, they will seal that place off with their red tape and the likes and tell you to stop work. So that is it. So to ensure compliance. So you know, in some instances in Nigeria, contractors, they are greedy or clients. So on the paper they say 2-story building, but on the side they are erecting 6-story building. Now it is all these LASPCA people, this Lagos State Building Control Agency, that will come and say that no, on the approved paperwork it is 2-story. Why are you going to 3, 4? I think we've heard of that building site at was it Ikoyi or so. They actually collapsed that year. You get where this man almost one of these high-rise buildings, yeah. So they said the man is maybe the man in charge of these high-rise buildings, or he's one more man like that. You get. So yeah, so we read of that man actually. So these are the courses. So they will seek for approval for 10-story building, and on the building side they will be erecting 20-story building. Imagine. So which means the requirement, everything, foundation, everything you actually submitted was for 10-story. You now want to build 20 on it. So you are going beyond the approved listing. It shouldn't be so. So that is the role of building inspector, to ensure such scenarios are avoided. All right. So we have safety officer to ensure a safe working environment on the construction site. They implement safety protocol. When they come, they will ask for your safety gadgets, your first aid in case of maybe accident or site injury. Is there any emergency procedures or guideline in place, stuff like that. So, and they provide training. Yeah, they provide training and conduct safety inspection. They will check your scaffolding. If you are going for a rise, are you using what you ought to use? Are you following safety standard and safety protocol on the building site? So you have the environmental officer. I think, yeah. So the Lagos waste disposal management, Lagos water people, all of them. Yeah, your site plan, this in your building approval will actually pass through all of these people, because they will check your sewage disposal, check everything, does it align with the state conduct and code of ethics. So all of these ones will actually come and check while the building is actually going on. All right. So you have the fire safety inspector. They must ensure that the building you are doing, okay, imagine the one that actually happened at Lagos Island a few weeks ago. The building actually caught fire, and I think 4 fire service and 6 workers from Escabit actually died in that building. Now imagine such building, high-rise building that has no emergency exit. no emergency exit. So that is why you see that most banks, they have this water this thing. So that thing looks like camera like this. I don't know whether we actually observe this, okay, in banks, whereby you be seeing something like small plastic under the ceiling like this, plenty at intervals. Now all those things are not camera, they are actually water passages. So in case they are smoke detectors, so in case there is fire outbreak at any section closer to the area, if those things actually detect that there is smoke, the water starts spilling. So before the arrival of fire safety people, at least if the fire is not that much, those water sprinklers can actually kill off the fire before the arrival of safety people. So all those safety measures should actually be in place, and that is the work of all these government agencies which we measure, which we actually mention. So that is actually in case they actually did their works as they ought to do. So you get, if Nigerian state hasn't actually entered them. So we have the planning officer. So that's the town planner. So they ensure that the building plans and projects adhere to local planning regulations and coordinate with other statutory authorities. All right. So from there, a building construction project involves the collaboration of various parties, each with their specific roles and responsibilities. All right. So the client party defines the project requirements and oversees its execution. The contractor party executes the construction work, and statutory personnel ensures compliance with regulations and standards. Effective communication and coordination among these groups are crucial for the successful completion of the project. All right, so that is very important, very important. Those three parties important. All right, so from there we have the preliminary operations in building construction or on the construction site. So imagine I got a land approval, everything, so, and they've actually done the approval, done everything. So the next thing I'm going to do there is what is site clearing. So site clearing involves the removal of vegetation or debris. So I just call Sanusi and Yakubu or Babatunde, hey, come help me to clear that building site. So they will go there and use their cutlass. In case of small projects, so you get like maybe one plot or half plot of land or two plots. So that one is manual site clearing. They use cutlass. But in case of maybe a big project, say an acre, 2 hectares, 3 hectares, and like, so they come with what, with machineries to actually what, to remove the debris and vegetation cover and topsoil also existing on the site to pave the way forward for construction. That is what site clearing actually entails. So removing the bush. Okay, so removing the bush. So site leveling is the reduction of the ground to approximately zero grading. So in some cases whereby the site terrain is not leveled, maybe it is a slopey area and the likes, so you might actually need to do some small leveling. So if the gradient is not too much, so you get, so you can actually do some leveling by bringing in machineries to grade the area, ensure you have what, a zero gradient or a flat surface for your construction, so as to have a stable base for your for your foundation. All right, but in case whereby the gradient or maybe the slope is very much, then there is a way at which a foundation can actually be erected there. I think there is this thing we call stepped foundation. Now in such cases, stepped foundation will be employed. So if the slope is too much, is entering maybe something 10, 15, 30 degrees, so you get this grade of that area, so you just employ what is stepped foundation in such scenario. So that's that about that. All right, so we have terminologies used in building construction. The first one is setting out. So after you've cleared the site, do soil testing, blah blah, setting out. So setting out is just like, oh, let me just give you a good example. So imagine a tailor, tailor that actually wants to sew a cloth. They have templates. They actually cut the shape on a paper, yes or no? So before they cut that shape on paper, they do what? They did measurements, yes or no? Even they can actually cut the clothes directly, but before they carry scissors and start cutting the clothes, they do the measurements. They will carry their tape rule and their chalk or pen and mark. It is after they've marked that they start what? They start cutting. So that process of marking, that process of interpreting my building plan blueprint on the construction site is known as what? Is known as setting out. Okay, it is the transferring of information provided in the working drawing by the designing engineers or architects to the ground. So that's it. So that is it, and it is carried out by civil engineers with the help of architect or a builder. And we have several methods of setting out. So the first one is the 3-4-5 method. Okay, so we have the 3-4-5 method, we have the builder square method, and we have the surveying instrument method. So those are the three methods for setting out. You can actually read more on those three methods: the 345 method, the builder square method, the surveying instrument method. All right. So that is that about that. Those are the three basic methods of setting out on a construction site. Another one is excavation. Now, after marking the length, breadth, the wall position, and the likes, you have to do all of those things. The next thing is what you start excavating, that is digging the ground, digging out those shapes which I've actually marked out. And you know, in a setting out scenario, you can actually start marking with chalk on a construction. What do they use? They make use of what? Of profile board and building line in most cases alongside the pegs. That's when you see them carrying all this wood that has a pointed mark. They start hitting it to the ground, so to mark out positions. So together with a profile board and building line. Okay, so to carry out what? After doing that, then they start excavation using digger. So they start using digger, but if it's a big project, they make use of machines. Okay, they make use of machines to actually excavate the soil. So just digging of ground, that's what excavation is. Excavation is a big grammar. So digging of ground, that's actually excavation. So tools and equipment used in setting out, we have reference peg, we have ranging pole. Ranging pole is actually used whenever you are using surveying instruments, theodolite. I don't know whether you actually seen it before. You can, that's why I say check it out. Check this 345 method, builder square, and surveying instrument method. Check it out. So check it out. So they use ranging pole in a surveying instrument method. So we have spirit level, we have profile board, we have builder's line, we have the theodolite itself, we have builder square, we have measuring tape, etc. Apato budget. All right, so from there we move to major components of a building. I think we are diving deeper. This class is kind of too long, but I want us to actually start the drawing proper. So let me just run through the theoretical aspect. All right, so for those who actually subscribe to this class, I will share a link where you can actually download this material from. Yeah, this material I'm actually using here. I'm going to share a link where you can download its PDF from. All right, I want to share a link you can download this PDF from. It's a Google Drive, which you will only access it with your email. The email you submitted to access the class is what you can actually use to access it. So take note of that. All right, major components of a building. Number one, foundation. After the foundation, floor. Yeah, that's just it. Should be after setting out, they do foundation. After foundation, the next component is what? Is the floor. Okay, after the floor, we have wall opening. After wall opening, we have roof. After roof, we have stairs. After stairs, you get. But I think these are the 5 major ones I'll be focusing on. So if there are other ones we need to focus on, I will be explaining that when we get to the drawing proper. Yeah, because I don't want to rush that drawing proper. I want to calm down and explain everything you need to actually understand. You know, we're actually using AutoCAD. Now I will be explaining how to do those things on AutoCAD, then also how to do them on paper. All right, I remember the last set, those who are in year 4 right now. All right, so after the assignment, everything done on AutoCAD, I think the exam, the man told them to use paper and pencil for exam. So you give them paper and pencil, then with OBJ. So that's it. So how to do this thing on paper, how to do it on AutoCAD, and how to do it on AutoCAD. You know, AutoCAD is entirely different from Inventor. So you get, but don't worry, don't let me run ahead of myself. Let me just calm down. When we get there, I will explain better, and you can please ask questions if you have questions. And for those of you who are not opportune to join this class live and direct, if you have questions, that is after you subscribe and you watch this video, if you have questions, don't fail to ask. Please note your questions in the next class. Please ask questions. You actually paid for this, so ask questions and enjoy your money to the fullest. All right, enjoy your money to the fullest. So foundation is the structural base of a building or structure responsible for transferring the load from the building to the ground. So the foundation transfers the weight of your building, first floor, second floor. It transfers it to the what? To the ground. Here you get, and ensure it spreads it uniformly. So the foundation ensures the stability and longevity of the structure by providing a firm level base to bear its weight and withstand environmental forces like wind, earthquakes, and soil movement. You know, there's this part of the Bible that says, if the foundation be destroyed, what can the righteous do? And I think one of the illustration of Jesus was one build his house on the solid rock, one build it on sand, and when the storm comes, the one built on sand, water wash it away, but the one built on solid rock would stand kidigba. Now the reason why you actually excavate your soil is to take away the weak soil so that you can have a more stable soil at the under. It is on that stable soil you now erect your foundation that actually carries the building. Imagine you want to build a structure and you start building on the top soil. That's what you are saying at the top. If rain fall, then you wash up the top soil now, and when it washes up the top soil, your building collapses, Jakarta. It's as simple as that. So that is why the need for excavation. And the deeper your excavation, the deeper your foundation, the more stable your building is. But does that really matter? Yeah, it matters. But also, the state of the soil actually matters also. The state of the soil. There are some things that actually determines how a foundation should actually be erected. I think, yeah, the first one there is the money at hand. The money you have, the type of building you want to erect. You can't expect me that want to erect a story building and a bungalow, or a high-rise building, 10-story building, to now use the same foundation. It is not possible. You know, it will be foolish of me to use a foundation I've used for 10-story building for a bungalow. Yeah, that's very stupid of me. I'm wasting money. And it is also foolish of me to use the foundation I will use for a story building, for a 10-story building. Yeah, I am the foolishest if there's anything like that going on earth. So it can't work. So you need to know what to do. And also, the nature of the soil actually determines the type of foundation to be used also. The nature of the soil also determines. All right. So we have types of foundation. Basically, the common types of foundations are strip, pad, pile, and raft foundation. Strip. So strip foundation is that common one that you are used to. So that shop that they have, not a story shop, that bungalow shop. So you get that bungalow shop that they build at the roadside and listen on a soil that has a good bearing capacity is what strip foundation. That fence, yeah, the fence of your house. If the soil of the area you are staying is a soil that has a good bearing capacity, that is, it is not waterlogged, then the foundation used for the fence there is what is strip foundation. Is strip foundation. Okay, so take note of that. All right, so I don't need to read through. I just send the material. You can read the material from there. So the second type foundation here is the pad foundation. So pad foundation, now if I want to erect maybe like, let's say, 1-story building, 2-story building, yeah, even 3-story building on a soil that has a good bearing capacity, I can use what? Pad foundation. I can use what? Pad foundation for that. All right. So then the third one is raft foundation. So raft foundation is actually used for a very high-rise building. Yeah, for high-rise building, or they are used for high-rise building on a soil that has low bearing capacity on a water-lodged area, especially water-lodged area, or soil that has low bearing capacity. So they use what? Raft foundation. And raft foundation is expensive, very expensive, very, very expensive. So the cheapest of all foundation is the strip. That one, you just excavate your soil, put your concrete binding, and put your block, and you are done. Okay, pad foundation, you introduce reinforcement. That's why that one is slightly expensive. Yeah, you've seen foundation whereby when they are making it, they are putting pillar. As they are doing the foundation wall, they are putting what? Pillar. Pillar is what I call column. Pillar is the local language, so that you get used to it. So the learned person language is called column. Okay, so whether you see them erecting column, maybe in fences or in structures, that is what? That is a pad foundation. Okay, so raft foundation covers the entire area. Yeah, and I think raft foundation, if you are, I think I was opportune to pass. Yeah, that new building they are building, Faculty of Education, that new building that they are erecting just now, the foundation used for that building is raft foundation. In raft foundation, from the soil they actually excavated, she gets to the surface, they don't use one single block. What they use there is what? Reinforcement and concrete. Reinforced concrete, to be precise. So you get, imagine a whole foundation of a big building and they did not use one single block. Everything there is what? Concrete and reinforcement, reinforced concrete. So imagine how expensive it is going to be. They casted everything. That is what the raft foundation actually entails. So, and it covers the whole building area. Not that they will cast one side and use block on the other side. No, they will cast everything, every area that the building is actually what? Actually covering. All right. So, and raft foundation are suitable where floors area are small and structural loadings are low, such as in 1 or 2-story domestic construction. A basement is required. So if you are constructing a building that needs a basement, so you get all these buildings that actually needs underground, so you use a raft foundation. Ground conditions are poor and strip or pad foundation requires significant excavation. So for example, on clay deposits, compressible fill, and so on. So a sandfield area, in a sandfield area, this is what they use. They use what? A raft foundation on sandfield area. You see all those sandfield as the, what's the name of this area that they are sandfilling now? If you are going to, if you want to climb Town Mainland Bridge at that Makoko side, that Baliga side, here you get. So those are the type of foundation they use in those areas. Raft foundation. Okay, raft foundation is what they use. It covers the entire building area and it is made with what? reinforced concrete. Reinforced concrete. All right, take note of that. So settlement of differential settlement is likely. So the fourth one there is pile foundation. Pile foundation. If you guys are actually familiar with those building, those high-rise building at building department now, that environmental science department. So at the back you see those high-rise building there. Yeah, those high-rise building. I think you started them before 2013. I remember then I was in FC when we were doing the foundation of this building. We were hearing boom, boom. Imagine building that building we are saying there. Its construction is over 10 years old. That building we are seeing behind Faculty of Environmental Science, all those, I think it is 2. Yeah, those high-rise buildings are 2. Yeah, that building is over 10 years since they've been constructing it. Those high-rise building. The foundation is pile foundation, not pile. That is, imagine somebody driving a pole, that concrete pole, like 3 of it to the ground until it reaches the hardest part before now making a beam where the foundation or where the building is now erected on. Imagine something like that. That is the foundation of those structures you are seeing behind environmental science. Yeah, those 2 tall buildings behind environmental science, they are made of what? Of pile foundation. So after they've dragged the pile to the ground, they now create a beam on it, and on that beam, then they now create a slab, a concrete slab on it. So that is it. That is pile foundation. They drive them in, and we have several types of creating pile foundation. We can do precast pile or cast in pile. Is this even part of the material I pieced together here? I think I'm actually saying too much, Abby. I think so. So I think I'm saying too much. Okay, let me just explain it. When they say something is precast and something is casting, precast is I've actually created the NEPA pole on the floor. I now convey it to the construction site. I was now driving it with hydraulic hammer into the ground. That one is precast. In precast now, those areas where the concrete did not reach, or maybe there is defect, I can actually see those things because those pile are what on the ground. That is precast. But casting, that is when I actually go to the construction site, excavate the soil, so you get pour concrete to it, then put the reinforcement inside. So I can't see anything on the inside. I can only assume that all is well. Alright, but I think those ones are that environmental science. Yeah, behind environmental science, I think those ones are precast because then the rate of boom boom we used to hear back then no more. No be here. Okay. Now, these are basically 3 types of foundation here. So let me just explain. Now, in a typical straight foundation, okay, if I want to excavate my soil, so let's assume this is our soil. I will excavate it like this. So this is my soil, okay. Yeah, I've excavated. So the gap of this place to this place that I excavated is going to be what? Is going to be 675. Yeah, our block, a typical block, that block that you call 9 inches block, a typical 9 inches block is, I'm coming on. Yeah, the thickness of a typical 9 inches block is what? Is 225 mm. Is 225 mm. That's it. So if I'm going to excavate my soil for a straight foundation, I'm going to excavate my soil to 3 times the width of my block. So 225 times 3 is what? Is 675. So this excavated area is what? Is 675. Is 675. That's the excavated area. Okay. And the concrete binding that will be sitting there, the thickness is going to be what? 225. Thickness of my block. So actually does it more than this. Here you get, but this is just the minimum. So after doing that, then your wall will now what? Sit in the middle. My wall will now sit in the middle like this. So let me assume I've actually filled all of this area with concrete. I fill everything here with concrete. So you get filled with concrete. Bang bang bang. So my wall, let me use grain for that. My wall will now stand at the middle like this. 1, 2. So you get, that's how my wall will now stand. My foundation wall will now stand like that. So you get pian, 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 pian. So that's my foundation wall. So you get, that's my foundation wall. So you get sitting inside the excavated area. So, and that is what, that is a normal strip foundation. So pad foundation, look at the pad foundation. So this base now, this base you are seeing here, and this column you are seeing as reinforcement, they are metal. Maybe the cheapest of it, there will be 4 iron rod standing, 1, 2, 3, 4. Now those iron rod is going to sit on the leg of the iron rod. Can either be like this L-shaped leg, you get, like that. They can be L-shaped leg, you get, and there will be something called a mat. A mat is going to be laid like this. It is reinforcement also. They will have bind this, and this L-shaped leg will now be sitting on it like this. 1, 2, 3, and 4. They will now carry it, place on that area. They will now pour concrete. So the whole of that is called what? Pad foundation. Why this is what? Pile. So imagine I have a building area. All of these are what? Are pile, concrete pile, reinforced concrete pile. So they are driven to the ground. After driven to the ground, okay, let me just give a quick graphical illustration of how a pile foundation is being erected. Okay, so imagine they've actually driven those piles to the ground. Okay, imagine they've driven those piles to the ground. So let us assume pile 1, pile 2. Maybe I have these 2 pile. Okay, so after this pile, now on top of this pile, I'm going to create a beam. So a beam is something like your lintel, right? A beam is something like your lintel. So that's what a beam looks like. A beam is something like this. Okay, usually rectangular or square, but it is made up of reinforced concrete. And so something like this will now sit on top. They will now do something like this on top. So let me use another color to illustrate that. So a beam is now seated. So this beam is going to connect. You see, the beam is going to connect the 2 pile together. So if it is multiple pile, you have maybe more than 2 pile or so. So the beam is going to what? Is going to connect all of them together. Now that's the beam sitting on top. Now imagine I have something like this here. I have a replica of that here also. So you get another beam now connecting like this, connecting like this. So you get, it is now on this. They will now create a slab. That thing you call decking. It is not called decking. It is local people that call it decking. They call it slab. The slab will now sit down on this beam. So you get, with the slab sitting on this beam now, and you have a floor you can actually stand on. So that is how it actually works. Alright, don't worry, when we enter drawing proper, I will show you what it actually entails. But obviously we won't be drawing pile foundation. We won't be drawing pile foundation. All we are doing is just basics of our building construction. Okay, so that is that about that. So this is an example of a raft foundation. You can see raft foundation, it covers the entire building area. Do you see any block inside this place? No. So now these are the wall, the foundation wall shape. You can see all of these places you are seeing are the places whereby wall will take. These are the areas whereby wall will take. Those are areas where wall will take. So you can see now. You can see the section of the rooms, but still on state they fill everything with reinforcements, iron throughout, and DPC. That line we are saying is DPC, and its function is to prevent the rising of soil water into the building. I don't know that you've been to some houses in that Bariga area whereby as rain is falling out like this, water will be coming out from the ground. It is because there is no DPC there. There is no DPC there. And if the house you are staying in, so you get, after rainfall, let us assume they haven't painted the wall, or even if they paint the wall and you notice that your wall is wet, you go outside and the wall is wet from the bottom to the distance, and you can't even put clothes inside the wall wardrobe, everything will get wet, then that house doesn't have a DPC. So soil water is rising from the soil, then penetrating into the building itself. So under normal circumstances, either being a raft foundation or slip foundation or whatever, a DPC should be introduced in between the flooring material so as to prevent the flow of soil water into the building. Now imagine, let me just take my time to explain. Imagine this is your floor. Okay, this is my floor. This is my casted floor. Okay, imagine this is my casted floor, but before that I have a polythene sheet like this, a polythene sheet laid somewhere on the under before they pour the concrete, as you are seeing in the picture here. So you have your polythene sheet. Now if rain fall, evaporation takes place now, soil water coming from the bottom to the top. So as the soil water is rising, as they are rising, so when they get to this polythene sheet, water can't permeate a nylon, a polythene sheet. So when they get to this polythene sheet, they will definitely go back to where you are coming from. Tapada or deshi is return. You don't have any choice than to return. That is that is because your house actually has a damp proof course or a damp proof membrane. But imagine there's nothing like that in your building. It is just a Baba Chinedu. Just let them do this thing. I park my load, go there. If they fall like this, and it is now a area whereby the soil is not that good. Anytime there is snowing like this, water starts and that is why you see some buildings whereby their wall will get wet. When you apply painting, apply any finishing, it will be peeling off. It is because the soil water is the one destroying it. That building does not have a DPC. No matter how they put wall rendering, when they render the wall, they do rendering, they apply paint, apply everything. After a few this like this, it starts peeling off by itself. It starts getting wet. Yeah, that's because there's no DPC there. So soil water is damaging it. So imagine. So instead of you doing aroro, selling fish, give your work to standard engineer. Don't do aroro. Okay, God will bless you. Give your work to standard engineer. All right. So that is it. So that's how that foundation actually looks, and this is its structural view. You can see. You see that damp proof membrane. You can see that damp proof membrane there is what is there. All right. So that is that about that. So from there we move to lintel. I think let me just bring everything out with the picture. Now you actually seen something like this before in a building. Okay, you've seen something like this before. When they build your structure to this level, carpenter people will come. They put pako left and right. Whether people will come, they will put iron on the inside and they will pour concrete. When they pour concrete, do everything. This is what you have. A lintel. So a lintel is actually placed ahead of a wall opening. And when we talk about wall opening, we talk about the areas where your windows and doors are located. That's where you actually need a lintel, because without this lintel and you don't want to arrange wall on top, if there's no lintel here, maybe you just use spark or whatever, maybe you just pour the concrete here, you do not put reinforcement, or you start laying block on top, everything will fall in Jakarta on your head. That's it will fall on your head. So lintel actually helps to give strength to structure overlaid at the top of a wall opening. All right. So a lintel is a horizontal structure that is provided above openings such as windows, doors, etc. in buildings. A lintel is also used to support projections like sunshades and lofts. The width of the lintel is generally the same as that of the wall. That's it. As you can see this one here, you can see the width of it. See this one too. Width same as that of a wall. It should take care of the load from the masonry above the openings. Masonry is referring to what? Block or bricklaying. Take note. Functions of lintel. A lintel is an important member that must be designed in such a way that it can resist the tension, compression, and shear force acting on it. On top of this lintel, you have walls, you have everything. Imagine there is no reinforcement inside this thing to collapse because there is a load acting on this area. So it is the lintel that is supporting those loads from tearing off into the wall opening. All right. So the lintel should also counter attack deflections. Yeah. So that's one of its actually primary purpose. Okay. So from there we have openings in walls. Wall openings are either doors or windows, which provides space in the solid walls. Yeah. So that space you have for your door, for your window, they are created as a result of wall opening. So a window is the wall opening that admits daylight into the building. Your window is not for aesthetical. The first or primary responsibility of a window is what? Is to permit daylight. Light before air. There are several buildings that actually have window. Meanwhile, you still have it inside it. So the first function of a window is to permit daylight. That is why if you want to design your building, give your building to original architect to design it for you. Imagine they design a building for you and NEPA doesn't bring light and the whole area on the inside is dark. On a broad daylight too, in the morning or afternoon, and the entire area of the building is dark. Yeah, that's because the planners of that building didn't actually put some windows at strategic places that will actually allow the permission of light into that building, even if there is no NEPA light. That's it. It shouldn't be so. When it is not a storehouse, if it is a store warehouse now, even in store warehouses, they still create this small fancy block this thing at the uppermost part that allows what? Daylight to penetrate inside the building so that you can see. So imagine you have a building and there is no light and you can that building actually stayed at Imo State only father during my NYSC. Broad daylight, you'll be only touch light when you enter. Imagine. Because where they want to put window, that's where they put bedroom. So imagine entering from the veranda on the outside to the lobby, and there is no passage of light at all till you get into your room. Because where they want to window, they put bedroom there. Imagine. So at times, if I'm at home during the day, I will just open the door of the bedroom down so that the light that enters the window through the window of the bedroom can actually shine into the lobby of the apartment. So that's just it. Imo people, when they try. So functions of wall openings. So the first one there is door. So the main or primary function of the door is to provide access to a building. Door is not for, yeah, there are some people that actually use door for fancy, but the first function before security is what? Is to provide access and egress. So ingress and egress, INGRESS and ENGRESS. Egress and ingress into a building. That's the function of a door. Because without door, the Bible says, he that doesn't pass through the door into the building is what? Is a thief. That's it. If you follow the window, you don't pass through the door into a building, you are a thief. Only you are a thief. So door is to gain access into a building. Alright, that is primary function. Alright. And primary function of a window is what? Is to admit daylight, not air, not fresh air. First thing first of the window is what? To admit daylight. So take note of that. To admit light into the building. So other functions of the door is to deny access to the building, to provide security, yeah, so that they will not come and attack me with my $1 billion at home. So to beautify the entrance, yeah, some people, if you want to do your Sunday or TGIF, thank God it's Friday, your Sunday picture, you go to that door. Because your door is fancy door, they now snap you, now do kiss you or kiss me. So that's it. So to beautify the entrance, all right, to provide fire resistance, to provide thermal and sound insulation. That's just it. My neighbor was saying that if they start playing music at my apartment, God have mercy, Sha. God have mercy. God have mercy. That's why I use headphone at home. Even indoor, I use headphone. Imagine. So we have window. We have window. Okay. Primary function of window is to admit daylight into the building. Other functions are ventilation, to see outside. Ventilation, that's passage of air. To have a view of the outside, security purpose, beautification, thermal and sound insulation. So that is a wall opening. That's a typical picture. So this door opening, you can see the space. That's a lintel sitting on top of it. This is a window opening, a wall opening, and this is a lintel sitting on top of it also. So take note of that. All right. So from there we go to roof. That's another structure we'll be considering. So a roof is a structure forming the upper. Yeah. For the window, for the doors, there are specific dimensions that are general to them, that are basic, because the man won't give you dimension when the drawing is going to give you in class. So we expect you to know some specific dimensions. So by the time we start the drawing paper, I will give out those dimensions by the time we start the drawing paper. And please ensure you are with your jotter so that you jot them down. All right. And I said that I will be sharing some. Okay, maybe I didn't state it in the announcement. I will be sharing some AutoCAD extension files with you. That's actually going to aid you rendering your building plan and other stuff like that. So let me just shut up. So by then, if you haven't subscribed to this class, subscribe. Tell your friends that they are missing out a lot. Yeah, those this thing I showed you earlier on, those stuffs. I think, let me scroll back. All these stuffs. Yeah, there are some of the assignments which the last set actually did. Yeah, you come now. Come. All this stuff you are seeing here. All of this one you are seeing here, you see all of these things, yeah, they are drawn by students like you. You see the rendering, everything inside, all those things you are seeing, they are assignments did by last set, yeah, after the training. So I know you can actually do better than them. You can do better than this. So that's it. Is this not a skill? That's a skill. Imagine you do something like this for somebody outside, standardized learner, and you bag your money sharp. Okay, so that is the beauty of it. You are learning for educational purposes and also skilling or upskilling yourself. All right, so that is that about that. So back to where I was before I digressed a little. So a roof is a structure forming the upper covering of a building or other shelter. It provides protection against rain, snow, sunlight, extremes of span to be covered, and so on. Now, the one you see on the outside is the roof. So the underside of your roof is known as ceiling. Take note. I am going to repeat this again. So take note. Okay. Now, this is what is your roof. All these ones outside, that's a what? That's a roof. So the underside, if you are on the inside, that part you are seeing on the inside is known as what? The ceiling. The one you are seeing from the outside is known as what? Roof. The underside of your roof is known as what? Ceiling. Underside is what? Ceiling. I need to bring my graphics tab next class to write properly instead of using a mouse. Yeah. So that's it. So the underside of your ceiling of your roof is known as what? Is known as ceiling. Take note of that. Take note of that. So purpose of roof: to protect occupants from adverse weather conditions such as rain. Imagine as the rain is falling this morning, your building doesn't have a roof. You are a gunner. You are a gunner. Sorry, you are a man. You not a gunner. You are a man. You are a man. So take note of that. So to prevent occupants from adverse weather conditions such as rain, snow, sun, etc. So to prevent excessive heat loss, yeah, to prevent excessive heat loss, to keep the interior building cool. Yeah, you see that morning as the rain is falling, the inside of the building is what? Is cool. Yeah, the inside of the building is cool. That's it. So classification of roof. So the roofs are classified into the following three categories. We have pitched or sloping roof. Pitched or sloping, which means all those roofs that have angle, that are projected like this. If you're, I'm showing the front elevation, a roof that is projected at an angle, maybe 30 degree. Example, the roof of almost all of our building in faculty of education are what? Are pitched roof, because they are pitched at one angle or what? Or two angle, either like this or like this. So you get, and this is your building. Say your window, your door. So you get, so that is what? Pitched or what? Or sloping roof. So we have flat or terrace roof. Flat roof, flat roof, flat roof. Any building in England actually has a flat roof. I'm not sure which building actually has a flat roof. So let me explain an example of flat roof. A flat roof is a roof that is decked. So you erect your building, you now deck the top. After you create the deck, which is called concrete slab, you now leave it like that. That is what? A flat roof. So usually concrete roof actually. And we have curved roof. Curved roof also, or known as what? Domed roof. Example, the roof of a mosque. You know, they are somehow elliptical like this. Okay, roof of a mosque somehow like this. See, you know, and some churches they are somehow like this, and the building will now stand under like that. Bam, curved roof or what? Or dome roof. That is the third category of roof. Those are the classification of roof. We now have several types under each of those classification. Okay, so that's it. So from there I move types of roof. Dome roof. This one is under curved roof. That's a dome roof. Okay, is a curved structure that have no angles or corners and encloses an enormous amount of space without using any supporting columns. It is usually used for government and religious building. I think our National Assembly, yeah, at Abuja uses a dome roof also. Yeah, I think so. Yeah, the National Assembly at Abuja, where the reps do their meeting, where they pack our money. I think it uses a dome roof, and most mosques, yeah, uses what? Dome roof. Okay, the number one is gable roof. Gable roof is the most common type of roof. Okay, that is the common roof in your churches, your apartment. Roof that has no design, that is just triangle. If you are looking at it, all you are saying is what? Is triangle. That is what? Gable roof. All you are saying is what? From the front, 1 and 2 all the way. So all this type of roof like this, and your building is what? Under like that. That is what? Gable roof. Gable roof. Okay, and it is a double pitch roof. Double pitch because has an angle here, has an angle here. That is double pitch. So if it is single pitch will just be like this, just one angle. Example of single pitch roof is the roof used at car parks. So you get, maybe you have a car park in your house. You know what they use there is was a single pitch. The pitch only is tilted to one side. So you get, and there will be pole or maybe wood carrying the roof here, and your car will go. Your car will be sitting inside like this, on the under like this. So you get, with the wheel. So that is what? That is a single pitch roof, and it's also known as what? Lintel roof. And this single pitch roof, some people also use it. Maybe after building their structure, they notice that whenever there is rainfall, you get, rain used to enter through the window. So they will now form. Okay, let us assume this is your building. They will now form this kind of this thing. Maybe this is your building. You have your window here like this, and rain used to disturb you. So you now see them. They will now form this, something like this. They will put wood here. The wood will come here and here like this. Pian. They will now use pan. The pan will now come over like this, where the window is, so that whenever there is rainfall, rain will not what, will not enter the window directly. It will now be what, coming, the rain will now be dropping here like this, bang bang bang. So that's also an example of what, of a single pitch or what, or lintel roof. You see, it's similar to the one used there. So that is that about that. That is that about that. So I've explained two things together. That I've explained gable and what, and lintel roof. Lintel roof is single pitch roof, while gable is double pitch roof. So we see have several examples of double pitch roof. Okay, so the third one there is hip roof. I think this hip roof, yeah, this is the type of roof. Okay, so quick one. That roof used where Dr. Fakoride's office is located. That building, that our mechanical lab. So it is a gable roof they use there. Okay, now you know that back space where Dr. Fakoride is a professor now. So where Professor Fakoride park his car, where they park their car. If you are going to that Mr. Pius, that gate beside Mr. Fakoride's, Professor Fakoride's office, you know there is something like a small shed there, a small shed that mechanic people work. That is an example of a lintel roof, a single pitch roof. Okay, now the roof used for am I correct? Michael, don't make mistake. Don't make mistake. Don't make mistake. Yeah, I think the roof used for that Dean's building, where the Dean office is, that roof that building that actually harbors inter-science lab, biology lab, physics lab. That roof is a hip roof. Is a hip roof. Okay, so a hip roof have slope from all the sides. It is slope from all the sides, left, right, front and back. It has slope, but a gable roof is only slope at two ends, either the left and right or front and back. That's it. Only slope at both ends. But a hip roof is sloped on the four sides. Slope on the four sides. And you can see the difference between gable and hip roof. Here you see. So that's it. In gable roof now, all of this place is what? Block work. They will use block to fill this place up. Bam. But in a hip roof, the roof will come down here like this. Come down on this side, come down on that side, come down on that side. That is the difference between the two. Alright. So we have butterfly roof. Yeah, they are using this kind of roof now, especially because what, it saves money, unlike hip roof or gable roof. Butterfly roof saves money. It's just like lintel roof. Butterfly roof and lintel roof. If you go to several building site now, you say most of the buildings they erect nowadays now, they use this lintel roof. You think they are doing design? It is a lie. They are trying to manage money because it won't take much more resources compared to gable roof. That's just bend it towards one side. PM was a lot. So this butterfly roof is also a double pitch roof, okay, because it is tilted at both ends. All right. You also have mansard roof. Mansard roof, yeah, this one eat a lot of money. All right. So I think this is actually used in most important. I think in all these company, industrial buildings are usually very tall. So some of them employ this mansard roof. Yeah, some of them employ it. Okay. So we have gambrel roof too. You see, just like mansard, it looks somewhat like mansard too. Okay. So we have parapet. Parapet is a roof that is flat, concrete roof that is flat. So you can see a flat concrete roof. So after this concrete roof, they now create this thing on top, which is called what? Parapet. This is a parapet wall, and on top of that parapet wall, there is a what? There is a coping. So now let me just explain this. I don't know whether you've seen fences. You know, a typical fence will look like this. So let me use color red. Let me use color red so as to stand out. You know, on a normal day, a fence will look like this. PM, 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 PM. That's the fence. Now, if I leave, and you know, my block house hose, there will be hose at the top. Yes or no? Yeah, there will be hose at the top of your wall, isn't it? Because of the block. Now, if I leave this block like this, it doesn't make sense. I don't know whether you actually see this whereby at the top, at the uppermost part of your wall here, they now put something like this. Let me use green. They now use something like this. At times, it might be something of this design. At times, it might be something of this design. They just do it on top of your. This will be your fence now. Here you get, it's going to be at the top of your fence. At times, it might be a rectangular concrete placed at the top. So whatever the design is, it might be half round, it might be like this. So you get, they just do it at the top of your what? Of your wall. Okay. Now I think this design here and this design is usually used for fences, where they want to put barbed wire, and they also use this one too for fences, also for barbed wire. But for a building that has flat roof, it is usually this one that they use, this one here. So they just create this flat stuff, rectangular this thing, yeah, concrete on top, piam piam. Now the purpose of this thing, aside from the beauty it adds to your wall, is to actually prevent rainwater from permeating. Imagine you now live, you have a concrete roof, you now live on top of the walls like this. Water will be entering into your building now. So to prevent that, they introduce a parapet wall. So you get this wall that extends, this wall of your building from here to here. Now if this is the roof, okay, let me use yellow. This is my roof now. So this wall, the distance from this area now to this height here, the distance of the wall there is known as what? Is known as parapet wall. The wall that extends beyond your roof is known as parapet wall. And this flat structure that they create on top of that wall to prevent the permeation of rainwater is known as coping. Coping. Hope you can see it. I'm using yellow, sorry. It's known as what? Coping. So that is that structure erected at the top of a parapet wall to prevent rainwater from penetrating into your wall. So take note of that. I might not remember to mention this as we progress, so take note of that. So if you have a flat roof, there will be a parapet wall, a wall that extends beyond the roof, and on top of that parapet wall there will be what? A coping. So if you have fences and they do all this design on it, all these design are known as what? They are known as coping, coping. And aside from adding beauty to your wall or your fence, its primary purpose is to prevent rainwater from what? From entering the walls. That's its primary purpose. So take note of that. So, and I think this is a E-proof. Yeah, this is a structure of a E-proof. You can see everywhere is what? Is sloped. Everywhere is sloped. On a E-proof, we have the hip and we have the valley. So the highest point, so you get the highest point. Now imagine you have this, the highest point. Oh, change color, guy. The highest point where our roof meets, that area is known as what? Hip. While the lowest point where they meet here is known as what? Valley. So highest point where they meet, you see this one, the highest point they meet at this high point here, that's hip. This place is what? Hip. This place where they is called what? Hip. But now this lowest point here, okay, this lowest point, see this inside is a low point. This place is a low point. Okay, that is what? Valley. Okay, so now the valley, there is usually a drainer inserted at the underside of this valley that actually allows water to come out. If you haven't noticed this, go and take note. If you have this kind of roof design. While at this hip, what they put there is a ridge cap, that flat metal. They just use it to conceal the space so that rainwater won't penetrate also. So on a hip, they apply a ridge cap. On the valley, they apply what? A drainer. So take note of that. All right, I think that is all we are actually going to consider today. So which means by our next class we are diving into the drawing proper. I think I'm going to actually drop a link for a Zid or an opinion box so that we can have more people online for time to fix for our next class. I think that should be better. Though I work in a school, but most of the time I think my work for now is Thursday and Fridays. I go to work on Thursday and Friday, but on Thursday and Friday, as from 6 o'clock, I think I'm free. As from 6 o'clock in the evening, I'm free. So maybe we can actually schedule our class for times like that, or probably Saturday or Sunday. Should you get? So that's it. So from there, okay, we have stair construction. Now, typically what the man actually wanted to know here is the types of stair, how they look like, and yeah, that's it. So and maybe probably a component of a staircase. All right, so stairs are structures designed to bridge a large vertical distance. Imagine I want to go from ground floor to first floor to second floor. Will I fly? No. So if there is not an elevator, I'm going to use what? A staircase. I'm going to use a staircase, and a staircase contains several steps. Now take note. So the whole structure is called a stair. So while each platform that you place your leg as you are climbing the stair is known as what? Is known as step. So step 1, step 2, step 3, step 4. So a single staircase might have up to like 10 steps before you move from ground floor to first floor. So take note of that. English. That's it. So examples of staircase, we have straight flight. So this one, I just climb, just single staircase. You just climb it, piam. There's no turning. You just climb from ground to first floor, second floor, hotel. Then yeah, so you see. So that's a straight staircase. So the second one is dogged leg. This dogged leg, I also call it half turn. I call it what? Half turn. Let me picture that one used at, yeah, so that our daily block, that block beside the tech studio, the houses, inter science lab, biology lab, physics lab, the staircases used in that block is a dogged leg, a half turn. You notice that as you climb and you reach that area where you rest small, that landing, that flat surface in between them is called a landing. Now you notice that you turn back to the position you're actually coming from, but you're actually climbing up. So that is a what? That is a half turn. That is a half turn. But in case by the time you climb, you turn either to left and right, then you continue climbing. That is a what? That is a quarter turn. But if you turn 180 degrees to face where you're actually coming from, then keep climbing, that is a what? A dogged leg or what? Or half turn. So take note of that. All right. So we have opening well. Yeah. So whereby you have well. So I think this one is actually common in area whereby you have plenty space. So in an area where you don't have space, you don't employ this. So never. That you don't employ this. Okay. So we have circular staircase. We have spiral staircase. Take note. Spiral staircase is usually used in places whereby there is limited space. It's usually used in a building whereby there is what? Limited space. This spiral staircase, you can see the plan. Take note of the plan. That's how you know that they are managing space. See the plan of spiral staircase. It is round. So the thing is just like you are moving around about a pool, just that you're actually climbing up. That's it. It doesn't take more space at all. That is why you notice that in most market store, all those evil boys, their store, they easily make this type of staircase, this spiral staircase, because you are just turning about the same area, but you are climbing up, because it actually helps to manage space a lot. So the staircase that helps you to manage space a lot is what? Is spiral staircase. You can see it will start from here, and see that's the only space it takes. You are just revolving, about the same axis. So that's it. You are just rotating about the same axis. It's as simple as that. So it helps to manage space a lot. So we have geometrical stair. So this one is used in all these, all these big fine building they use for acting movies now. And this one too, you see, you have plenty space to actually waste. So you can see here, see this quarter turn. You climb from here, PM, and you turn 90 degrees, PM. Unlike that one over there, whereby you climb like this, PM, you turn 90, then you turn another 90, PM. So you are going through this area, then when you reach here, you come through and you keep what? Climbing like this. That's half turn or dogged leg. Why this one here? Like this, then what? Like this, 90-degree turn. That's what? Quarter turn. All right. So those are the several types of staircase we actually have. So I'm going to share the material on that link for those who actually subscribe to it. You have access to it. So I think I'm going to actually stop here for today. Yeah. Oh, component of a staircase. I won't stop. Let me just finish it and follow so that we can enter drawing proper. So please, against our next class, before we fix our next class, let us try and install our AutoCAD software. So the same way you actually install your inventor, that's why I'm going to install your AutoCAD. And please, it is AutoCAD though, not AutoCAD building this. I think there is AutoCAD architecture, not AutoCAD architecture. Just normal AutoCAD is what you are installing. Normal AutoCAD. So not architecture. Take note. Normal AutoCAD is what you are installing. And the details you use to activate your inventor, that your school email, those of you use school email, Microsoft this thing to activate, you don't need to register. That is the same thing. Just input that email and the password, PM, it will activate your AutoCAD for you. So far it is still a family of Autodesk. This thing, Autodesk are the creator of AutoCAD, Inventor, Revit, and the likes. So the same email and password still works for everything. So take note of that. So we have components of stairs. All right, so the first one here is what? Is the tread. The tread is that surface that you place your leg on, and that flat surface that your leg stamps on. That is what? The tread, where you step in. So the riser is the vertical height. Yeah, let me just show that. So the height from here to here, that height. Okay, I think let me use more tiny this thing. The height from here to here is your riser. the height from here to here is a riser, because it is it that actually allow you to rise before you have another what, another thread. So you have another thread, a riser, a thread, a riser, a thread. That's how life goes. A riser, then what, a thread. That's how life is. A riser, a thread, a riser, a thread. So take note of that. So you have the stringer, the structural support that holds the thread and riser in place. All right, you have the handrail. Yeah, that one where you place your hand. You have the balusters, the vertical post that supports the handrail. So these are the balusters. All these vertical stuff you are seeing here, all these vertical this thing, they are what, balusters. Okay, newel posts, the main post at the top or bottom of the staircase. So this first one here, okay, on the outside here, and this one here is the newel post. Sorry, why the ones on the inside? The ones on the inside are the baluster. Take note of that. The one on the inside is the baluster. The one at the edges is the newel post. Take note. The landing, the flat area. Yeah, you know, I was mentioning that building, the house is the dean office in Faculty of Education. You know, when you climb, I think that staircase is a dogged leg, a half ton. So you know, when you climb the first one, you have the flat surface where you rest. So imagine a pregnant lady, you can't just climb at the go, you rest. When you rest, you now turn, then you continue. So that's the landing, the flat area at the top or bottom of the staircase. And you have the waist, the area beneath the staircase. This area, the waist. So just as all of you have waist, your staircase also what? It has waist, but it doesn't have enough. Sorry, it only has waist, and it doesn't have bumbo. So I think that's all. Yeah, that's all. Yeah, and that brings us to the end of the class. All right. Once again, my name remains Oluwatumbi Blessing or Lalekon, the founder of MaekllTech, and it is nice having you for this class. Yeah, I actually need to actually go through all of this so that we can actually have much more time to tackle the drawing proper itself. And mind you, I will give assignments which I expect you guys to do so that you can know where you guys actually need help, or wherever you make mistakes, that you can actually correct it. All right, so it's nice having you for today's class. Thank you very much. See you next class. Thank you.